Hello and welcome to podcast.init, the podcast about Python and the people who make it great. When you're ready to launch your next app, you'll need somewhere to deploy it, so check out Linode. With private networking, shared block storage, node balancers, and a 200 gigabit network, all controlled by a brand new API, you've got everything you need to scale. Go to podcastinit.com/Linode to get a $20 credit and launch a new server in under a minute. To get worry-free releases, download GoCD, the open-source continuous delivery server built by ThoughtWorks. You can use their pipeline modeling and value stream map to build, control, and monitor every step from commit to deployment in one place. And with their new Kubernetes integration, it's even easier to deploy and scale your build agents. Go to podcastinit.com/GoCD to learn more about their professional support services and enterprise add-ons. And visit the site at podcastinit.com to subscribe to the show, sign up for the newsletter, and read the show notes. Your host as usual is Tobias Macy, and today I'm interviewing Tivadar Danka about modAL, a modular active learning framework for Python 3. So Tivadar, could you start by introducing yourself?
Yeah, so hello everyone. I'm really glad to be here. My name is Tivadar, and I'm a postdoctoral researcher at the Hungarian Academy of Sciences. I work in a group called Bioimage Analysis and Machine Learning Group, BioMag in short. And basically, I did my PhD in pure mathematics 1.5 years ago. But after I finished my PhD, I decided to do something which actually can help make the world a better place. So I joined a bioinformatics group, and we are analyzing microscopy images of cells and actually helping drug discovery, helping physicians, doctors, creating diagnostic tools. In brief, this is it.
And do you remember how you first got introduced to Python?
Yeah, basically I was introduced to Python 1.5 years ago when I introduced myself. So as I mentioned, I became interested in bioinformatics, biology, bioimage analysis, and I needed to pick a language. So I had 3 options: Perl, R, or Python. And I was advised against Perl because it used to be really popular in bioinformatics, but now it's not that popular. And my other choices were R and Python. So I basically tried Python. I really enjoyed the syntax. I really liked the language, liked that I can do many things in a really easy way, not like C, which I had some prior experience back in the day when I was a university student. So bottom line, I choose Python, and I really glad I chose Python.
Great.
This is how I was introduced.
And so in the introduction, I mentioned that the project we're talking about is a framework for active learning. So I'm wondering if you can just describe what that terminology means.
Okay, yeah. So active learning is actually a machine learning tool. It falls between supervised learning and unsupervised learning. It's actually a subset of semi-supervised learning, when the premise is that you have a small set of labeled data and a bunch of unlabeled data. And what you would like to do is to improve your understanding of your data, improve your classifier accuracy by using the unlabeled data. And the main feature of active learning is that it actually asks you questions about the data. It asks the human expert to label some examples which it finds most useful. So, for instance, a typical scenario is that when you have some kind of classifier, for instance, you want to classify tweets, sentiment of tweets, opinions, and you have a small set of labeled data and 1 billion tweets which are unclassified, and you want to pick some unlabeled instances which would give you the most amount of information for your model. And active learning is actually like basically a set of tools trying to help you choose those instances. So basically it measures the informativeness of the unlabeled instances, and after that it presents it to the oracle. I mean, it can be a human, it's not always a human, and then it includes in the next question. So it retrains the model and then asks a question again and again and again until the model is refined enough.
And so, as you mentioned, having the labeled data for being able to do the training is necessary to increase the accuracy. And what are some of the challenges of being able to actually obtain properly labeled data for these data sets to be able to get the necessary accuracy from these machine learning models?
for instance, I work in biology. So sometimes the greatest difficulty is that you have billions of cells for which you would like to find the phenotypes. So our basic setup is that we have a bunch of cell cultures or tissues, and we screen them with a microscope. And in these screens, you have like a billions of cells and the billions of images for each cell. And you need to classify the cells, for instance, which is a healthy cell, which cell has a cancer mutation, and so on. And if a researcher or a doctor sits down and starts to annotate the cells, it's not that representative. So you cannot really browse through billions of cells and expect to get a nice training data set by random. Okay, so I'm just going to continue with another challenge, right? Okay, so another challenge is that not all phenotypes are discovered by the biologist, for instance, because you can have something which you don't just stumble upon. So this is not included in your training set. So your unlabeled data set actually has labels which you didn't see and you don't know it exists. So one of the greatest challenge for us is to find those instances of the cell which can actually help you define new labels. And this can be done by, for instance, exploiting cluster structure in the data or doing some kind of spatially balanced sampling in the feature vector space and so on. Another challenge is to actually try to explain the biologist what kind of questions can they ask about the data, to be honest. Okay.
And for some data sets, there are companies where you can actually do things like crowdsource having the data labeled. So whether it's images, having people look at them and say, this is a car, this is a dog, etc. Or, if it's just doing something like sentiment analysis, having somebody go through and label whether it's positive or negative sentiments or whether there's sarcasm. So for certain fields, particularly in the area of bioinformatics, I imagine that there's some difficulty in being able to just have any random person appropriately label the data. So I imagine that that's why you need to be able to do the sampling technique of surfacing only certain subsets of the data to have somebody with domain expertise label it appropriately. Is that accurate?
Yeah, exactly. So this domain expertise is really important. It's also, if I just sit down and start labeling cells, we won't get anything useful because I'm a mathematician and a computer scientist. So I don't have domain knowledge in it, but the biologists do have domain knowledge in it, and you cannot crowdsource it. Even if you may crowdsource it to many biologists, but this may not also be viable because people are really specialized. So if you are studying certain types of cells, certain diseases, certain markers, certain phenotypes, you can only find like really a handful of person who is an expert in this field, and they may be competing with each other. So they may not be willing to help each other out in this sense. So yeah.
And so the project that you built is intended to be able to simplify the process of surfacing some of these subsets of the data for labeling. So I'm wondering if you can just discuss a bit about what the project is and how it works and your motivation for starting it in the first place.
Okay, so actually modAL was built, it grown out from a research project, which I did. So basically, I am trying to develop active learning strategies for something called active feature value acquisition. And I came up with a lot of these query strategies. Okay, so a query strategy is basically the technical term for this selecting an instance which is the most informative and presenting it to the biologist or so. So basically, I came up with several query strategies, and I developed an actual framework where we can test these strategies. And I have developed in a way that it is compatible to every scikit-learn model. This framework can be used with any scikit-learn model, basically. So when I did this research project and this was kind of the model prototype was created, I realized that it may be useful for other researchers and other persons who are actually applying active learning in practice. So I decided to make this like a complete package, make it so that other people can use it. So basically, this was my biggest motivation. So first, it started out as something for me, a tool for myself. But basically, I realized that actually it can be a tool for other people. So I created it, and I made like documentations, tutorials, and one of my main aim with this is that I would like researchers to help actually develop active learning strategies. And this is why I created modAL in a way such that if you would like to replace the underlying modAL or replace the underlying query strategy, you can do it in a single line of code, and you don't have to change anything else. This is why I call it modular, because I designed it in such a way. So even if someone is not an expert in Python or in programming, he or she can actually use this tool really easily to prototype active learning workflows. So this was my main motivation.
And so as far as being able to obtain these labeled data sets and bring domain expertise to the overall process, I don't know if you're familiar with, there's another project called Snorkel that takes a slightly different approach where they have the domain experts write various functions that will apply labeling to the data by running it through certain algorithms, whereas you're using human in the loop to be able to surface interesting data points to ensure that you're getting the most value for the time spent. So I'm wondering if you can just discuss a bit about some of the differences in approach there and some of the relative challenges of doing that human in the loop approach as opposed to just having a function that can run across the entire data set.
Actually, I am not really aware of their approach. I haven't heard of the Snorkel you mentioned, but it's really interesting. I will check it out. Okay, so difficulties with the human in the loop. Okay, so first of all, it's obvious, but even a domain expert can make mistakes, right? So the data you get can be noisy. This is one problem which can affect your result. Ideally, it's not the case, but sometimes it is. So you have to be aware of that. Another problem maybe is that actually selecting out that specific instance which you want to query can take you a lot of time. So many of these active learning algorithms are like really computationally heavy. So it can take you several minutes to present like an unlabeled example to query. And if you present the labels by I don't know, random, you may get even better performance, because by the time you present the sample, present the unlabeled example, if you present them randomly, you may label 10 times as many data. This is actually a challenge which needs to be overcome. And about the Snorkel approach, I'm not sure if I can comment on that, because I'm not entirely sure.
Sure. And so when you're using modAL for being able to surface these interesting data points to be labeled, what does the typical workflow look like for being able to run through from start to finish of having a desired model that you're trying to build and picking out these data points to ensure that you are getting the most value for time spent?
Basically, what you need is two things in this workflow. One is a scikit-learn model, and one is a query strategy, which are implemented in modAL, some of them at least. And after you train your model on some kind of initial data, you can initialize an active learner object from modAL, and then you present you give in the query strategy and the model, and then actually you have just simple two methods: the query method, which will use the query function, the query strategy you presented, and find you the most informative instance, and the teach method, which actually teaches the model for these newly acquired labels. And this is as simple as it gets. It's a few lines of code. And if you want to replace the modAL or the query strategy, you simply need to change like one line. So if you would like to test out several strategies, you can do it very easily. One of the very important stuff which is missing from modAL, which I plan to include it, is like an interactive labeler. So right now it's basically just a high-level wrapper over scikit-learn models. But what I would like to do in the future is that I would like to write a labeler which can actually help you label data interactively, preferably from a browser, maybe. But a typical active learning workflow is really easy with modAL. It's just 5 or 10 lines of code.
And what are some of the metrics that you use when you're picking out the data points to be able to determine which ones will actually improve the accuracy of the model versus the ones that are within the range of accuracy that you're already working with?
Okay, it's a really good question. This actually lies at the heart of active learning. So let me just give you like a quick baseline and then some kind of more sophisticated measures. The most baseline measure is classifier uncertainty. So if you have like an already trained model, you can actually make predictions for your unlabeled data set, and you can measure the uncertainty of those predictions. And one of the simplest things which you can do is to pick out those instances which have the highest uncertainty. But this cannot fall short because if you think about it, it's really, really short-sighted. It cannot discover you new phenotypes, and it's really, really biased by that particular model which you have. But sometimes it's a good baseline model, so it can actually give you better performance in some cases. One other very, very baseline query strategy is the entropy of the predictions. So you have the classification uncertainties. Basically, the higher the entropy, the more useful this instance will be to you. This is something which you can use, but this is also sort of short-sighted. It's biased to the classifier which you actually have on your hands. So what can be done against this is to actually have several classifiers forming a committee, basically, and deciding the next query, the next instance to be labeled by some kind of disagreement measure. So you can imagine you have like 10 classifiers. Each of them were trained on different data, or even they may be like a different model. So one can be a random forest classifier, one can be a k-nearest neighborhood classifier. So somehow they each capture different aspects of your data. And what you can do to kind of help this short-sightedness is that you can measure the disagreement between these models. For instance, there will be some instances where the models are completely agreeing. You can suppose that there your prediction is good. There you don't need to improve. But there are some regions in the space where your 2 classifiers or 3 classifiers or how many classifiers you have are actually having like a large disagreement. You can query based upon that. This is like a little bit more sophisticated example of these query strategies. Also, there are query strategies which can actually exploit structure in the data. For instance, you can have clusters in really high dimensional data, and you can ask labels from the clusters, which you use some kind of hierarchical clustering or so. This also helps you to kind of explore the data and overcome the short-sightedness.
And is there any sort of general rule of how many data points you need to label for being able to get the desired outcome with the machine learning model? Or is it more a case-by-case basis and highly dependent on the data that you're actually working with?
Yeah, I wish there would be, but unfortunately I think there are no such. So you cannot really tell that, okay, if I sampled 1,000 data points, then I will be okay. I think it's heavily dependent on your data.
And so you mentioned that the primary framework that you're working with for modAL is scikit-learn. I'm wondering if you have any intention of, or what the difficulty would be for extending it to support additional frameworks such as PyTorch or TensorFlow or Keras.
It actually supports Keras because Keras is so a scikit-learn wrapper is provided in Keras. So you can actually take your Keras models and wrap it so that it will have the scikit-learn API, and those models you can use right away. So Keras support is implemented. I think this is one of the best features of modAL is that you can use these deep learning models with Keras. And I'm also planning to do this for PyTorch and TensorFlow. But this is like for the future. But this would be really important. Yeah.
And what have been some of the most difficult or challenging aspects of building and working with modAL?
Okay, so as I mentioned, I'm a mathematician, and I had basically no formal training in computer science and software development, so I'm completely self-taught. So my biggest challenge was to write maintainable and readable code for others to use, others to improve, others to contribute. And this was one of my greatest challenge, basically, and I really focus on this to do it right. Also, a challenge was that in order to have a general framework, you need to design like a really good API. You need to design the right classes, and this was also one challenge for me because I really had no prior experience in object-oriented programming. So in some sense, this is my first project. So yeah, this is one of the greatest challenge, but I actually really enjoyed this. I really enjoyed designing the API and employing these design patterns. So yeah, from the algorithmic side, it was not that big of a challenge because I speak the language of the algorithms, and then I'm just a newbie on speaking the language of software. But I hope I will do a nice job. Yeah.
And you've mentioned some of the goals that you have for future versions of modAL, but are there any sort of broader plans that you have for future developments or improvements, or any direction that you want to take the library going forward?
Yep. So basically, one of the first agenda which I have is that I would like to include Jupyter notebooks with the examples. So this would be one of the most important part because, as I mentioned, one of my goals is to make it usable for everyone, and Jupyter notebooks are great for teaching purposes. So this would be like my immediate next job to do on my list. Another thing which I would really like to include is Bayesian optimization. So probably you have heard about Bayesian optimization. It's an optimization technique which you use where the evaluation of your objective function is either really expensive or you don't have gradients. For instance, if you have like a deep learning model, you want to tune the hyperparameters. And in order for you to actually experiment, to try out hyperparameters, sometimes you need to teach it for several days. And what Bayesian optimization does is it actually like builds a Gaussian process regressor, or practically any kind of regressor, but mostly Gaussian process regressors are used between the parameter space and the performance space. So basically it tries to predict the performance from the hyperparameters. And it has some kind of feedback loop which is really similar to active learning. So it actually finds you those hyperparameters in the hyperparameter space which you should explore, and it would give you either an improvement or it would really give you like a new information. And I actually included some kind of baseline Bayesian optimization objects in modAL, but it's still experimental right now. So I would like to improve it. For instance, I would like to be able to optimize over like really weird search spaces, hyperparameter spaces. And this is not strictly active learning, but it's really closely connected. So the principle is the same. So you have some kind of space where you have no information. You ask questions and you ask the next question based on the answer you had. So it's actually the feedback loop is completely the same as with active learning. So this is one of my main goals. Other is this deep learning support. It would be really important to support PyTorch and TensorFlow because they are really important parts of this field. I mean, you cannot really avoid TensorFlow and PyTorch. So I would really like to include the support for this. Currently, I'm the only developer of modAL, and I would welcome any feedbacks, any issues, pull requests, contributions. So please, if you have any ideas or have any suggestions for this, I mean, feel free to comment me or even send a pull request. I would be really happy.
All right. So for anybody who wants to get in touch with you or follow the work that you're up to or contribute, you will have your contact information in the show notes. And so with that, I'll move us into the picks. And this week, I'm going to choose the movie rendition of Peter Rabbit. I watched it with my family the other week, and it was hilarious and very entertaining and well done. So I highly recommend that for anyone. And so with that, I'll pass it to you, Tivadar. Do you have any picks for us this week?
Yes, so my pick is a book and an online course about the same subject, basically based on the book. And the book is written by a scientist called Yuri Allen, and the title is An Introduction to Systems Biology, Design Principles of Biological Circuits. And the reason I picked this is that it's kind of common knowledge in computer science that many algorithms were inspired by nature or biology. For instance, evolutionary optimization or even neural networks were inspired by biology. But in some sense, the opposite is also true. So what we kind of created, it has an analog in the living system. So actually, it was like a really, really life-changing experience for me when I realized that cells, bacteria, organisms are actually programmable. So you can actually program organisms to express like Boolean functions, and this is kind of explained in this book how you can do it. And it was like as I said, a fascinating and life-changing experience for me. So if you are fascinated with evolutionary algorithms or neural networks or kind of the effect of biology on computer science, you can also try to look at it from the other perspective, and this might be also really interesting to you. So this was my pick.
Well, thank you very much for taking the time out of your day to discuss the work that you're doing with modAL. It's definitely an interesting project and one that seems to be adding a lot of value to the biological research community. So thank you for that, and I hope you enjoy the rest of your day.
Okay, thank you for the opportunity. I would also wish for you to enjoy your day, and I would also like to thank you for listening.